Hi everyone, welcome back. In this video, what we're going to understand that how to write the solution to the wave equation if we have some arbitrary direction of the electromagnetic wave. That's that is if wave is wave is traveling in some arbitrary direction. How to write the electric field or how to write the magnetic field in that case, or simply the solution to the wave equation. So general wave equations are del square E equals 1 over c square dou square E by dou t square, or like in terms of magnetic field, del square magnetic field equals 1 over c square dou square magnetic field by dou t square. So these are the wave equations in terms of electric field and the magnetic field. Now, where do I write the solutions of these two wave equations when the wave is traveling in some arbitrary direction? Like in this case, what we have wave propagating along z-axis. So it's propagating. This is the direction of propagation. Direction of propagation, and electric field is varying along the x-axis. Let's say this axis is the x-axis, so electric field is oscillating along the x-axis. So x cap is direction of polarization. Okay, till now we discussed all these cases in the previous videos, like when we have x-axis, y-axis, z-axis, wave propagating maybe along x, y, z, and polarization is along maybe x, y, or z. So I discussed all these things in the details, how to write the electric field and the magnetic field, or simply how to write the solutions of these equations. Like in this case, so wave is propagating along positive z-axis. So electric field is given by E naught cos of kz minus omega t plus delta. So this phase factor will decide in which direction, since this and this is having opposite signs. So wave is propagating along this z-axis, and the polarization is along x-axis. So this is the x cap, and we know the how to find the magnetic field. 1 over c, whatever is the propagation is along the z-axis, so z cap cross electric field. I hope you understand this thing. But what we are going to discuss for this video is not these cases, but the electromagnetic wave is traveling in some arbitrary direction. Let me draw. Let us assume this is some electric field is varying in this direction. So this is electric field, and let us assume this is the direction of propagation. K vector is the direction of propagation, and magnetic field, obviously it must be perpendicular to the both. So this is the magnetic field coming out of the plane, and obviously uh, this is the direction of polarization. In which direction the electric field is varying, like that decides the direction of polarization. Obviously in this case, this axis in which direction electric field is varying, so this is the direction of the polarization. How to write the electric field and the magnetic field for this situation when we have some arbitrary direction? So this time the arbitrary direction of the electromagnetic wave. Now very important thing is that this wave vector plays very important role. So this k vector, we called it as a wave vector. This plays actually very important role in writing the solutions to these wave equations. So k vector is actually magnitude of k, and it's into k cap. Okay, so where like k is the whole wave vector, and mod of k is the magnitude of that vector, and k cap is the direction of the propagation. So k cap actually decides the direction of propagation. Okay, now the solution is like this: E equals E naught cos of k propagation vector, whole vector, dot r cap, or vector, r vector, minus omega t plus delta n cap. Let's understand a bit. So this r cap is simply the position vector in coordinate, a simple Cartesian coordinate system, x x cap plus y y cap plus z z cap, and this k vector is mod of k into k cap. This is like whole vector, and whenever we write this solution, we have to replace this k vector by this thing. But we know k is equal to this magnitude k. This magnitude k is actually it is actually 2 pi by lambda. This is the magnitude of the wave vector. Or if you're not compatible with this, I have already derived k in the previous videos. I believe that is also equal to the omega by c. This k is actually omega by c. Let's try to understand how it's omega by c. So sorry. So let's omega is 2 pi into frequency. This is the omega, and divided by c, that we can write frequency into wavelength. So frequency will go, so it's 2 pi by lambda. I have done it in a very different way in the some previous videos, so you can have a look on that. Probably that is not necessary right now. You can remember it. This mod of k, which is actually the magnitude of the wave vector, which is 2 pi by lambda, and it's also equal to the omega by c. Okay, so what we do in this equation, this we will always replace this k vector by this thing, omega by c into k cap. So it will become E vector equals E naught cos of mod of k is actually omega by c, and k cap dot r vector minus omega t plus delta and n cap, where n cap is the direction of polarization. Obviously this is the direction of polarization. We don't have any idea which direction is that right now, because why we wrote is as n cap, because n cap we consider a unit vector in the direction of electric field. So because electric field, the direction will decide the direction of polarization. Now one more important thing, what is this k cap? Now how do we find this k cap? K cap is actually this k cap is actually decided, this is the decided by direction of propagation. So it's a unit vector. I know it feels a bit confusing, but when I take the example, it's very easy. So how to find the k cap? So k cap is actually uh, uh, is actually uh, uh, the vector divided by magnitude. This is the general formula. A unit vector is given vector divided by the magnitude. And what's the k? What is the k cap? So we don't know this thing and this thing to find the k cap, but k cap can be easily found from the direction, because if a wave is propagating from 0 origin 0 0 0 to 1 1 1. Okay, so this k vector is actually 1 I cap or 1 x cap plus 1 y cap plus 1 z cap, and then k cap can be written as this vector 1 x cap plus 1 y cap plus 1 z cap divided by magnitude 1 plus 1 plus 1. I hope you all know these things, how to find the unit vector. Unit vector is given by the whole full vector divided by the magnitude. Let's assume like wave is traveling, if the question says the wave is traveling from like 1 1 and 1 to 3 3 3, there's some like arbitrary direction. Then how to find the k cap? K cap can be found by 3 minus 1 is 2 I cap, like, or plus 2 j cap plus 2 k cap. This is given vector. This is the given vector. Then k cap can be found with given vector divided by magnitude of the given vector. All right, so like 2 I cap plus 2 j cap plus 2 k cap divided by root of 4 plus 4 plus 4. Okay, so you have to be very smart. Omega by c, you write it there, and then there remains k cap. So k cap can be found from the direction in which the wave is propagating, and they will tell you in the examination or in the question in which direction the wave is traveling. So they'll give some 2 pointers or some vector. Okay, or either they give the pointers or they give you directly the vector. Okay, then you do given vector divided by magnitude, you find the k cap. Now then we'll do dot product of the k cap with the position vector. And what is position vector? Position vector is simply x I cap plus y j cap plus z k cap. I hope you understand how to do this. I know it feels a bit confusing right now, but when we'll do the question, it's very easy. It's very easy. Okay, see, let's do directly a question, then you'll understand what I mean. So question is, wave is traveling, we have to write down the electric field and the magnetic field. Okay, for okay, so this is the electric field. Then we'll also understand from the question how to write the magnetic field. So in the question, we have been asked to write down the electric field and magnetic field if like wave is traveling, if electromagnetic wave is traveling in direction from origin to the point 1 1 and 1 with polarization is some, let's assume polarization is some n cap. Okay, there is no data that gives polarization, so let's write it n cap. So how to write the electric field? Electric field is E naught cos of, now no need to write the k dot r, we don't need this k dot r, or you can go from the k dot r, then you have to write this equation. So write directly omega by c k cap dot r vector minus omega t plus delta n cap. Now this k cap we have to find. So k cap is k vector divided by magnitude of the k vector. So k vector we have to find from this origin. So it's like origin is here 0 0 0 and 1 1 1 is here. So this is the k vector. So k vector is like 1 I cap plus 1 j cap plus 1 k cap divided by root 3. Okay, 1 plus 1 plus root of 1 square plus 1 square plus 1 square. So this is the k cap. Now we have to do k dot r vector. R vector is given by x I cap plus y j cap plus z k cap. Now what is k cap dot r vector? Which is let's say, let's take this out, 1 over root 3. Okay, 1, so it's x, 1 into x, I dot I is 1 plus it's y plus z. So this is k dot r. Okay, so E is given by E naught cos of omega by c, and this whole thing k cap dot r vector can be written as 1 over root 3 x plus y plus z minus omega t plus delta some arbitrary direction. Okay, I hope you understand this point. So we can keep it like that. We don't have any problem in writing this. Now there might be some conditions given, like if the initial phase is 0, if like n cap is they might give it's some alpha x cap plus beta z cap. They can give the direction of the polarization. So this is actually the electric field. Okay, and in order to find the magnetic field, now magnetic field, how to find the magnetic field? So for the magnetic field, we'll use simply 1 over c, simply the equations we were using. k cap cross electric field. Simple. And k cap we know, k cap, we already calculated this thing. This is the k cap. Okay, so like it's 1 over c. In terms of k cap, we can write it as 1 I cap, like I cap plus j cap plus z cap, or k cap. Let me check. Yes, divided by root 3, cross product of this thing with the electric field. And electric field, we already calculated this thing. Okay, e naught cos of omega by c 1 over root 3 x plus y plus z minus omega t plus delta n cap. Okay, so this whole thing gives the magnetic field. Okay, I hope you understand the idea. The idea is very simple actually. The idea is like, or you can use a very different formula as well. Since k cap divided by c is actually, we can write it is like 1 over omega k vector cross electric field. This formula you can also use in order to find the magnetic field, because in the previous videos I have discussed how this formula comes into existence, actually how this formula we get. So this is actually same. This and this and this is same. Okay, why this and this is same? Because like, c is c, speed of light is actually, it's omega by omega by k. If you don't know, this is the coefficient of time divided by coefficient of x. Okay, and it's like omega is 2 pi frequency, this is 2 pi wavelength, and this will go, so it's frequency into wavelength. So c is omega by k, equals frequency into wavelength. Okay, but since we can write here k magnitude as omega by c, and we know k vector is actually magnitude of k into the k cap. So like k vector can be given as, let's substitute this is actually the magnitude here. Okay, let's substitute this thing in here, like omega by c k cap, and let's say take this omega, this downwards, it's k vector divided by omega, it's k cap by c. We can replace this k cap by c. We can take this c into inside, then replacing k by k cap by c as k vector divided by omega. So this will become as k cap by c will be replaced by the k vector by omega cross electric field. Take this omega outside, 1 over omega k vector cross electric field. We can also use this equation. Then it depends upon what is n cap. Then you must know how to do the cross product. That is a second thing. I hope you understand. So the basic funda is that when we have some random direction of the propagation, so you must know what is this k vector actually. So either you get either they'll directly give you the k vector, or simply you have to find it from the question. Like if they tell you the wave is propagating from this point to that point, so you have to use the basic vector fundamentals to find this k vector. Then we can do one thing. We can like do dot product of this k vector and that position vector. Position vector is like general, this is general position vector, always there. Okay, like, or you can do one thing, we can replace this k vector by omega by c into the k cap and find k cap by using the k vector divided by magnitude, and then substitute there. We'll easily get electric field. And this n cap is always, they'll give you the idea how to find the n cap in the question. Okay, maybe let us assume that they say it's x cap plus y cap divided by root 2. This is the direction of the electric field, or the direction of the polarization, the direction in which the electric field is varying or oscillating. Maybe like they give you some n cap is x cap minus z cap divided by root 2, or they say n cap is x cap plus y cap divided by root 2. They'll give something, the direction of the polarization, and this k cap you can easily find. Then we do the dot product of this k cap with the r vector. Then it's simple substitution then. Okay, I hope you understand it. I hope it's a bit helpful. Now you can have a look on the question from the David J. Griffiths question. Okay, electromagnetic waves. There is a good question there. You can solve it. Thank you. Thank you so much.